Hello everyone, this video tutorial will explain the basic concept and steps of the higher Psulu game. The mission of the game, the underwater robot from its beginning position to its ending position. The idea behind the game is that when we plan a path for the robot, we need to consider various resources and constraints and break it down into smaller legs. One important concept in this game is called a risk budget. On the top left, the risk budget it's suggesting that the total risk we can take for completing a whole trip can be allocated to the parts of the trip, which is called legs. The total default risk budget is 0.055, and the other concept is called surfacing budget. The unpredictable current in the water may deviate the planned path for the robot. So the longer the robot stays under the water, the greater uncertainty of its actual position. So taking shorter legs can minimize the uncertainty. However, every surfacing consumes energy and exposes the robot to the public, so choosing more steps per leg may travel longer distance each time and reduce the number of times to surface. But it may also increase the uncertainty its location. Now we will walk through the steps of the game. Step 1, enter participant ID. Here you can enter any unique ID that is for your record. And then step 2 is to choose a map. You have two options, either to choose from maps that are already created in the map library, which you can also see all of them in this gallery. And once you choose a map that is satisfying to you, page. For example, if we choose the obstacle 6, 10, once you choose this map, you can apply, so the map will be loaded to the system. And if you are satisfied with this map, you can click next, otherwise you can choose another one. So the next step is start planning. As we talked before, risk tolerance per leg is how much risk you assign to this particular leg. And you can choose from 0 to up to 0.202. And for the number of steps per leg is how many steps you want to contain for each leg. The bigger the numbers, the longer distance normally it takes, and you can choose from 0 to 12. So for this practice purpose, we choose the middle one to have a look what it looks like. So after you visualize the path, you will see the direction of the path and the distance, and the green circle shows the possible location of the robot when it travels. And also on the risk budget bar, the brown bar shows how much risk this planned path is going to take. If you are satisfied with this path, you can click execute, and then you will see after the robot execute the path, it's not exactly the same as planned path. This is due to the uncertainty in the water caused by the current. And on the risk budget bar, you see this black part is actual consumption of the risk, and the green part is the remaining risk budget, and you can also read the number to the left. Okay, so we will continue planning the path for each of the legs, and you can visualize and change the risk tolerance and number of paths until you find one that is satisfying to you. Okay, so as you can see here, the top of the surfacing budget is reducing, and we'll continue plan for the remaining part. As you can see here, the green bar turns to red. That is giving you an alert that not much risk budget is remaining. We can reduce the risk budget for the rest of the trip. This looks good to me, so we're gonna execute. Okay, so it's a successful trip. We'll click OK, and if you want to download a copy of the data, click OK. And then the data will be downloaded as a CSV file on your computer. And if you open up the computer document, it shows the participant ID, time, result, and real pass total sum. That's the surfacing steps, the total cost of risk, and the total risk budget. And also has the coordinates of the obstacles. You can import this document to SPSS for further analysis. If you have any feedback or questions, you can send it to the corresponding personnel on the contact page of this game website, Dr. Li Xiaohuang or Si Yang Chen. And thank you for watching.